Alright guys, good morning. We're going to do some notes here on our next little topic here called partitioning a segment. So here I just have some graph paper, so just follow along, write down in your notebooks. We don't have any like worksheet notes or anything. Okay, so we're going to work on this partitioning a segment. Partitioning a segment. Okay, and we've been working with lines, right? So this line, segment, it's all the same thing. Okay, so partitioning a segment, we're going to be looking at a line. Okay, and our question here is, what are the coordinates of the point 3/5 of the way from A to B. Okay, so there's a lot going on here. What are the coordinates? Okay, so it's asking us for coordinates of a point, and they want to know the point that's 3/5 of the way from A to B. So let me draw a picture here. We have A right here. Let's see, draw this here. It looks like our y-axis is, this is at -4, and this is at 0. Here's our x-axis. Okay, and then B is over here. Oops. Let's actually move this guy over. It looks like there. So in between, so each of these little squares represents two units. Okay, so here there's two squares between 0 and 4, -4. So that means that this one here is going to be -2, right? And this is going to be 2 as well. Okay, and it looks like B is C. This is 4, 6, 8, 10. This is 12. Looks like B is at 13 and 11. So here is 2, 4. Uh-oh, we might run out of room here. 2, 4, 8, 6, 8, 10. This would be 12. Is that right? Let's move this graph around a little bit here. Yeah. See if I can snag this whole thing. There we go. I'm just gonna move it down and over. That looks good. Okay. So A is at 3, -4. Okay, and B is at 13, 11. 2, 4, 6, 8, 10. So right here in this middle. Okay. All right, here's B at 13, 11. Okay, so this is what we're given. See if I can. Just gonna make it straight for me. There we go. All right. Now we have the straight line from A to B. So let's revisit what our problem asked for again. What are the coordinates of the point 3/5 of the way from A to B? Okay, so it's really important to look at where we're being asked to start. Okay, from A to B. That means we're starting at A here, and then we're going 3/5 of the way up, and then at some point on this line segment, we're gonna have a new point 3/5 of the way to B. So if we were to separate this line segment into 5 equal sections, we want to go up 3 of those sections and find the point. So I'm going to say it's probably going to be around here-ish, right? This is if we did 1, 2, 3, 4, 5. 3 of those 5 sections up is going to be our 3/5 of the way. So let me get rid of this. And let's see where that is. So we're going to solve this mathematically, right? Because we can't just guess and then say, yeah, that looks close enough. Okay, so let's look at what this means mathematically. Well, when we partition a segment, what we need to do, step 1 is going to be to find 3/5 of the horizontal and vertical distances from A to B. Distances from A to B. All right, so I'm going to do this one. Let's do a different color here. I don't like blue. Let's do red. Christmas is coming. Okay, so let's start with the horizontal distance. Just going to shorten that horizontal distance. Okay, and we want to know what 3/5 of this horizontal distance is. Well, how do we do that? Well, first let's find what the horizontal distance is. Okay, and we said that distance, remember, distance is the absolute value of one of the numbers minus the other. And here we're looking just at horizontal. And which part of the coordinate represents the horizontal distance? Well, x does. So we're going to be looking at 13 and we're going to be looking at 3. Okay, so our horizontal distance is going to be the absolute value of 13 minus 3. And 13 minus 3 is 10. What's the absolute value of 10? It is just 10 because it's already positive. Okay, so we have the distance, and now we want 3/5 of that distance. Okay, well, 3/5 of 10, that of represents multiplication, right? And that's exactly what we're gonna do. We're just gonna multiply 3/5 times 10 and see what we have here. Well, we're gonna be multiplying these fractions, so let's make this one a fraction over 1. Now we have 3/5 times 10 over 1. Some of you might see a short, quick way to finish this by reducing here, but let's just continue on the long way. 3 times 10 is 30. 5 times 1 is 5. Can we simplify this? Yes, we can look at this 2 different ways, right? This fraction bar is represents division, so we could just do what is 30 divided by 5, which is 6, or we can divide the top and bottom by 5, and then we'll get 6 over 1, which is equal to 6. Okay, so this is 3/5 of the horizontal distance is 6 here. Okay, so that means that our point is going to have an x value, right? Because x represents horizontal of 6. So, we'll finish that in step 2. Okay, so 3/5 of the horizontal distance is 6, and then we want to find 3/5 of the vertical distance. Okay, so vertical distance here. Okay, it's still going to be the absolute value of the 2 vertical numbers, one minus the other. So we have 11 and we have -4. Okay, the absolute value of 11 minus -4 is equal to, well, when you subtract a negative, it's the same thing as adding, right? What is 11 plus 4? That's 15. The absolute value of 15, it's already positive, is equal to 15. So let's find 3/5 of that. 3/5 of 15, right? Just like we did before. Now we have 3 over 5 times 15 over 1. That gives us 45 over 5, which is equal to 9. Okay, so now we have the vertical and horizontal distances. So let's go to step 2. So step 2 is going to be add the horizontal distance. Okay, and this is going to be the 3/5 of the horizontal distance, which is 6, to the x-coordinate. And let's do vertical distance, and the vertical distance, which we found was 9 to the y-coordinate, point A, which is at 3, -4. Okay, and that's step 2. And let's take a look at this. We're adding the vertical distance, which is 6. Okay, we found that 3/5 of the vertical distance, or sorry, the horizontal distance was 6, and then 3/5 of the vertical distance is 9. And those are the numbers we're going to be adding to point A, which is 3, -4. And why are we adding them to point A? Well, let's go back here and see. It wants us to find 3/5 of the distance up the line segment from A to B. So that means we're going to be starting at A here. Okay, so let's do this then. So point A is at -3, at 3, -4. Let's pick another color. Let's do orange. No, let's do purple. Point A is at, the x value is at 3. So let's add that horizontal distance 6 to 3. Our new point is going to be 9. And then let's add the vertical distance, which is 9, to the y coordinate of A, which is -4. So -4 plus 9 is 5. Okay, so now we have this new coordinate here. This represents 3/5 of the way from point A to point B. And now let's plot that on here and see if it's kind of where we thought it was going to be. So 9 is going to be here in the middle, and then 5 is going to be here in the middle here. So we're going to go up, and it's going to be right here, which is pretty close. I think my original one was like up here a little bit more. But you can see visually now that if we had split this into 5 different pieces, right, we have 1, 2, 3. This is 3/5 of the way up, and this is the 4/5, and then, you know, the last one 5/5. So we can see that this is 3/5 up the way. Okay, so here are your steps again. So make sure you have these. These will always be your steps to partitioning a segment, right? You'll just have to put in what the ratio is of the current problem you're working on. And then you'll add those distances to wherever your starting point is. So those are the things that's going to change, but everything else is pretty much going to stay the same. You're going to do the same thing with every problem. Okay, so in your textbooks, if you turn to page, I believe it's 23. Okay, so I want to do this right now after finishing this video. Page 23, you'll see example 2. This is the example that I just did here for your notes. Okay, so you can see the visual again. They have a graph there. They show you 3/5 of the horizontal distance, 3/5 of the vertical distance. It's a little bit cleaner on the book, so if you want to just read through those steps again just to make sure you understand what's going on, that's probably a really good idea. And then just below example 2, it has the try it. Okay, these are the ones we've been doing in class too, right? Number 2, it says find the coordinates of each point described, and then A asks you 7/10 of the way from A to B, so you're still going to be working with the same graph here. So if you drew a nice graph, you can really just use that. You can plot points on there to make sure it looks 7/10 of the way or 4/5 of the way. Okay, and then B asks you 4/5 of the way from B to A. So the main difference there is you're actually going to be starting with B, okay, and then you're going to be going down this way. Okay, so you're probably going to be, so your vertical distances, these numbers over here, 10 and 15 will remain the same, right? You just need to find, for the first one, 7/10 of those, and then add those distances to A. But for part B, 4/5 of the way from B to A, you're still going to use 10 and 15. You're going to do 4/5 of those. Okay, and once you have these new distances, you're actually going to be subtracting those from the B coordinates, okay, because you're going from B to A, so you're going 4/5 of the way down. So here's 1/5, 2/5, 3/5. So your point is probably going to be somewhere around here, and just by eyeballing it, I'm going to guess it's going to be 6,2. I don't know. Let me know if I'm right. Okay, so that's what I want you to work on now for the rest of class.